these are the batteries that keep us moving, right? So every time you're getting up chair, you're going for your jog or your walk, that's the energy, the currency is at the foundation is being created by these mitochondria. And so at the end of the day, when you're fatigued or you're having this lack of clarity, that's just the energy deficit of your mitochondria not being in top shape.
In today's episode, we discuss the science of your mitochondria, the energy powerhouses of your cells. We are joined by guest expert Dr. Anurag Singh, MD, PhD, and Chief Science Officer of Timeline Nutrition, a company that manufactures an advanced supplement called Urolithin A that improves mitochondrial health. If you want to live a long and healthy life, you need to understand how your mitochondria work and how to keep them healthy. And in this episode, Dr. Singh discusses the science of mitochondria and how lifestyle interventions like exercise, fasting, and targeted supplementation with compounds like Urolithin A are essential for energy production, a long life, and peak performance.
These mitochondria in the muscle cell, there are thousands of mitochondria, and they're really a network. Think about the energy grid powering the electricity in your local town. That's how they are. They're really very closely knit. So you need to have a very good network of healthy mitochondria communicating with each other, and that can be improved with nutrients such as coenzyme CoQ10.
All right, Dr. Singh, welcome to the Fit Father podcast. We are so happy to have you here and to have a great discussion on mitochondria, energy, longevity, and the exciting compound Urolithin A that you are a champion of. Thanks for being on the show.
Yeah, thanks for having me. Absolute pleasure.
So it would be nice to get into a little bit of background on your journey into medicine, into medical research, and why you've zoned in on mitochondrial health. And a little bit of your background and credentials would be a nice place to start.
Sure. So I'm by training a internist. So I trained in internal medicine early on, initially in India in one of the top med schools, and then I moved to the U.S. to train further in sort of the space of allergy and immunology. So then I became a trained immunologist. Ended up also doing a PhD in immunology, studying how immune system declines with aging. That was kind of my, foray. I was lucky to be mentored by really top MDs who, were like me, inspired me to kind of focus on the root cause of a lot of chronic diseases rather than the end game, which is the symptomatology. Is how most medicine is structured today, right? It's to treat the medicine, use medicines to treat the symptoms, but not really the foundation of the problem. And so that got me interested, and I was also lucky enough to be, when I was training in fellowship, I got introduced through a naturopathic doctor who was actually trying to get his PhD at the same time in the same lab into natural compounds. And I became fascinated by some of the immense health benefits these compounds had. That led to almost 20 years running clinical trials for big and small companies around the world, mostly in US and Switzerland for a long time. And I've spent a lot of time in researching aging. So I see myself more as a longevity expert, and every area, every organ system that I studied, whether it's the immune system or the skeletal muscle system during the aging, all roads kind of always hinted to mitochondrial biology being impacted. And so that got me interested in looking at natural compounds that would, boost, re-energize the mitochondria that decline during aging.
Phenomenal. Great breadth of experience, and it's so cool how it's led you deeper into the fundamentals of the mitochondria. And that's actually where I want to start. I want everyone who is listening to this podcast today to leave here with a deeper understanding of how their cells produce energy, how those pathways break down as we age, and how actually restoring those pathways through lifestyle interventions and targeted supplementation is actually the key to living a long life. And please allow me to set the stage for a second and then expand on it.
Sure, absolutely.
Life on our planet, like these cells that make up anything, a human body, a plant, we ultimately know we're producing ATP, cellular energy is what's occurring. And there's many different ways to do that, but at least with the human cell, eukaryotic cell, we seem to have in some span of evolution engulfed a bacteria called a mitochondria and developed a symbiotic relationship with it, where we eat and we do the foraging as a larger creature, and ultimately it all ends up in our cells, and these mitochondria, these little bacteria that we have a symbiotic relationship with, and now one that is so deep, I mean, coded into our genetics, are what produce energy for us. So we eat food, end product of that metabolism when things are functioning optimally is in the mitochondria. Can you speak on that and expand on that, if that feels like a fair
Yeah,
enough?
yeah, sure. That's a great segue. So you're absolutely spot on. So mitochondria are these ancient bacteria that co-evolved with us. We provide them with the nutrients from our diet, and they kind of integrated with our cellular machinery to help us metabolize a lot of these nutrients. And in many ways, everybody hears this in school biology textbook, that they are the powerhouse of the cell.
Mm-hmm.
Now, what that means are these are the batteries that keep us moving, right? So
Mm-hmm.
every time you're getting up chair, you're going for your jog or your walk, that's the energy, the currency is at the foundation is being created by these mitochondria. And so at the end of the day, when you're fatigued or you're having this, lack of clarity, that's just the energy deficit, of your mitochondria not being in top shape. And so that's what I want your listeners first to take away. Now, the second is, as we have co-evolved, these uh, powerhouse of the cell have also been influenced by our metabolism and our aging
Mm-hmm.
process. And the other cool thing about mitochondria is a lot of them they have their own separate DNA, okay, that we
Yeah.
call mitochondrial DNA. So, which is separate from the human sort of the DNA. So there are times when you have mitochondrial DNA problems, and there are kids who have muscle problems or neurological problems. And so a lot of this DNA is inherited from the maternal side. And so
Mm-hmm.
there's a lot of research going on in this area, but I won't go too deep into it. The problem that happens with aging is, think of mitochondria as the batteries on your cell phone. Okay.
Mm-hmm.
When your battery is fully charged, it's green. That's the peak of mitochondrial health. And now think about your phone with 10% charge and it's showing as kind of red, a little red, and only left. That's what happens to mitochondria with aging. You only are working on this little reserve because they get damaged. They accumulate what we call reactive oxygen species,
Mm-hmm.
oxidative stress. Not to get too nerdy, but they get damaged, and we can't really clear these damaged mitochondria out, and that's the problem that happens with aging.
Mm-hmm. Yeah, and I think that is important. So when people hear that term, reactive oxygen species, another word that's thrown out is free radicals. And effectively, from a chemistry, physics perspective, these are compounds that are unstable, that bump into things and damage them and create further oxidation. And when our DNA itself gets damaged, that can be a precursor to cancer. When the lipids on our cells get damaged, that is, basically synonymous with inflammation and all the cellular signaling that
Mhm.
happens off of that. So we need to keep our mitochondria healthy. And also mitochondria, I think of them like housekeepers, like naturally, even just through the course of a life cycle. We're in our homes, we're making food, we're making garbage. Like we just build stuff up from regular cellular respiration. Even functioning mitochondria create
Mhm.
a degree of reactive oxygen species, correct?
Yes, there's always what I call a yin and yang, and the balance is always, there's only so much real estate inside a cell, and there's always filled with mitochondria that are healthy, that are producing energy, then there are mitochondria that are getting damaged in that process of producing energy. But as long as this cycle of healthy and unhealthy is in balance, it's okay. But the moment the balance shifts towards the real estate being more on the unhealthy side, that's when problems really start happening at all stages of the aging process.
And I can see that, like the modern human living today, high stress lifestyle, always in sympathetic, which has a damaging effect on the body on many levels.
Hmm.
Inflammatory foods that are
Hmm.
also harming gut health and
Hmm.
allowing leakiness and proteins in the thing, and not enough exercise to stimulate the mitochondria. So it's
Yes.
like a whole concert of no wonder we're feeling stressed and fatigued and all these things. And so the root of it, with all healthy lifestyle interventions, good nutrition, adequate sleep, hydration, exercise, actually helps those mitochondria get stronger and better. So I've heard in some of your other talks that you talk about a couple different things you can do to boost the mitochondria. One,
Hmm.
you can trigger biogenesis, new mitochondria.
Hmm.
Two, you can increase the efficiency of your existing mitochondria using specific supplements. And three, you can trigger the mitochondria to basically get digested and recreated as new ones. Like
Mhm.
mitophagy is the technical term. I'd love to spend some time going through those subtly different aspects of how we can trade our mitochondria. And then if you can, as we go,
Mhm.
talk about some of the lifestyle interventions that people are aware of, and now they'll have
Yeah.
an understanding of how that fits into this architecture of mitochondrial health.
Sure. Yeah. So let's go through these three pathways of mitochondrial, let's say, health that are absolutely key or critical to how we function, how we metabolize energy. One, you mentioned something called biogenesis. Now, that really means creation of newer healthy mitochondria. Okay. And they are very effective strategies to help us create in our cells newer healthy mitochondria. They're nutrients like NAD boosters. Typical ones are nicotinamide ribosides, which is basically a precursor of vitamin B3. There are things from the skin of grapes, a compound called resveratrol. All these are well known, and they're markers we can look in, let's say, blood cells. If we see more of a marker called PGC1 alpha, that just means it's a signal that's a marker to that you have more biogenesis. The second vertical is something we call, the mitochondrial efficiency pathway, which is basically more of fission and fusion. Now, these mitochondria don't exist. If you look at a very high resolution electron microscopy picture inside a cell, these mitochondria in a muscle cell, for example, there are thousands of mitochondria, and they're really a network. Think about the energy grid, powering the electricity in your local town. That's how they are. They're really very closely knit. So you need to have a very good network of healthy mitochondria communicating, with each other, and that can be improved with nutrients such as coenzyme CoQ10. Now, this is a molecule actually made inside the mitochondria, which is essential for the transport of energy through the mitochondria. And there are things like creatine, L-carnitine that also do this. The third, which I believe is also very critical, is a pathway called mitophagy. Now, what is mitophagy? It's essentially autophagy targeted to the mitochondria. Autophagy means self-renewal, self-eating behavior. When cells are stressed, you talked about, this stress through various ways, our sedentary habits, our diets, all these things kind of damage cells, and the cells will say, put out these eat me signals. Now, when that's specific to damaged mitochondria, that's what we call mitophagy. And mitophagy is always happening, but just slows down with the aging process, and we get a lot of damaged mitochondria. And so, if you could activate mitophagy, you could actually take the damaged mitochondria out, much like a Pac-Man game, eating all these damaged mitochondria, and you will use them as building blocks for new healthy mitochondria. So these are the three strategies. And back just quickly to your second point, what are the other, let's say, lifestyle intervention strategies? The two most effective ones are exercise and caloric restriction. And
Yes.
every compound that I mentioned has been benchmarked to these two interventions.
Yes, and that's the thing is like exercise, I think particularly cardiovascular exercise, but strength training is great too,
Yeah.
stimulates mitochondrial biogenesis.
Mhm.
Period, full stop, that's great. Getting the body in any signal where it feels like it's lower in energy, we're activating that AMP kinase pathway through
Mhm.
fasting or exercise is going to stimulate the body to both recycle through
Mhm.
mitophagy as well as build new mitochondria. So this is why these interventions of exercise and good eating and calorie restriction and intermittent fasting work. They work on many levels, but one of them is these signals to the mitochondria. And so that's fantastic. And I also think there's this a paper that you reference often, a paper in Cell on the
Mhm.
hallmarks of aging, and they talk about how there's a couple different aspects of aging. One is mitochondrial dysfunction. Another is like senescent cells, basically cells hanging around that aren't really helping. They're kind of taking up resources, and so autophagy generally helps, but mitophagy specifically is so huge. So, kind of maybe mention that for a little bit. A couple of different hallmarks of aging that mitophagy or mitochondrial health is a part of that.
Yeah, sure. So, these were initially described as 9 key biological hallmarks of aging, and they don't exist in isolation. They're almost like a circuit board, right?
Yeah.
If one goes down, it affects the other, kind of. And you mentioned it. There's mitochondrial dysfunction. I believe is really the centerpiece, kind of the central traffic light that is linking all these pathways flowing in the cellular machinery. Then there's cellular senescence. So basically your cells become more fatigued, more zombie cell like. Then there is stem cell exhaustion,
Hmm.
similarly tied to cellular senescence. There, your body or your cells have this small portion of cells that are always self-renewal, kind of have a very high potential. They kind of decline with aging. Chronic inflammation, I believe this is a very underappreciated biological
Yes.
pathway that links, again, much like mitochondrial dysfunction, a lot of these hallmarks of aging. And then the other key ones are problems with macroautophagy. So mitophagy and
Mhm.
autophagy slows down. And the last one is gut dysbiosis. So somehow all these link, and I believe the two main central themes are the mitochondrial dysfunction and chronic inflammation.
Right. And then I think to extrapolate that another layer, I think then it's like for chronic inflammation, I mean, today's day and age, by and large, it's the foods that people are eating. We're eating inflammatory foods that are damaging the GI tract. For
Absolutely.
example, like glyphosate, the Roundup sprayed, it is an antibacterial. It disrupts the shikimate pathway, which affects your gut microbiome, which when that's all screwed up, all the inflammation is going to happen upstream from what happens in the digestive tract, or at least a lot of it.
Hmm.
And I think it actually disrupts the mitochondria too, along with some other antibiotics. And I'm not like anti-antibiotic ever, but we've clearly created problems with our modern lifestyle that's making inflammation a very common experience for people. And these things directly impact mitochondrial health. So it's all so tied.
Absolutely. I mean, I got interested in mitochondria because I was looking at metabolic syndrome in older adults a lot, and everybody was in statins. And believe it or not, a majority of these folks, and statins are wonderful drugs, but a side effect of them is mitochondrial dysfunction. So in the skeletal muscle, and a lot of people come with muscle cramps and all these problems, but it's really down to the mitochondrial toxicity of statins.
Yeah, that's a very unfortunate and brutal side effect. But it's I guess it's part of that current strategy. I think it's a good time to talk about Urolithin A, and I'd love to do it. This is the compound that you're a champion for, and Timeline Nutrition. You guys produce the purest and most clinically backed version of Urolithin A that people can take as a supplement on a daily basis to
Mhm.
stimulate this mitophagy response. And I want to get into some of the studies in a second, but I think it's important first to talk about the digestive health and how urolithin A is naturally formed,
Mhm.
in ideal circumstances, so people can understand prebiotics, postbiotics, and how urolithin A fits into this whole picture.
Sure. We're, you know, I'm a physician scientist, and we always aspired to be a life science company. And we started with this idea of doing a deep rooted scientific endeavor, looking at thousands of natural compounds and finding the few that had these immense health benefits, much uh, that would delay the aging process. And so we actually started looking at superfoods 15 years back. And so this is a summary of 15 years of research, how we stumbled on urolithin A. Now, what we found was it was not, and we focused in on pomegranates, and we found that
Mm-hmm.
the pomegranates have a lot of antioxidants or polyphenols, as scientists would call them,
Mm-hmm.
in the peel of the skin. So the white stuff, the good, not the shiny arrows, but the white stuff is very rich in a class of antioxidants called allegitannins. And
Mm-hmm.
what we found was it was not the allegitannins that were giving the health benefits that were associated with consumption of pomegranates, but it was actually the transformation of these group of polyphenols by the gut microbiome into something called postbiotics, and I'll get into what a postbiotic is. And that postbiotic molecule was urolithin A, which was giving all the health benefits. Now, what are postbiotics? Different from prebiotics, which is basically things like fiber that is food for your gut microbiome, and different from probiotics, which are essentially bacteria that you're taking, live bacteria, to help your gut health and your gut microbiome ecosystem. Postbiotics are like the end result of a very healthy gut microbiome. So they are, in many ways, the pharmacy of the gut microbiome
Yes.
that is influencing the host, which is us, the humans. And so when we stumbled on urolithin A, the first thing that struck us was that not everybody could make urolithin A. So we went to Italy, we went to France, we went to Canada, US, and everywhere we ran these studies, giving everybody a glass of pure pomegranate juice, we found in countries where Mediterranean diet is very common, so they're eating fermented food,
Hmm.
taking everything, it was about 30-40%. In
Wow.
countries where, so Italy, France, 30 to 40% natural, albeit in different levels. So some would have it in what I call therapeutic ranges, some would have it in very low circulation that would not give you a health benefit. But when we went to this, let's say Canada, US kind of environment, it was almost down to like 10 to 15%, which probably is because of, well, people are not eating a bowl of berries
Hmm.
and a glass of pomegranate, but to a certain extent is because of the inflammation with the dietary
Hmm.
and lifestyle choices, that also induces gut dysbiosis. So then we said, okay, this is almost like a new vitamin or a new nutrient that has, and we started seeing its effects on mitophagy, which we discussed in the past, and it was kind of a molecule that kept, across species having these immense health benefits, and we can talk about it.
Yeah. Well, that's fantastic, and I think that was a really good explainer of why gut health is important, so we can get these postbiotics. Urolithin A being a great one, and also I'll say this, and you can correct me if this statement is not true. This may not be true for everyone, but incorporating more foods that have precursors, allagitannins, so pomegranates, walnuts have some as well. I think maybe some teas may have some certain tannins, maybe not allagitannins, but feeding more of the food that the specific bacteria like to use for their own metabolism can probably increase your populations over time of those bacteria. Is that fair to say generally or not true? And what I'm saying, eating more pomegranates gives you a likelihood that you'll get more of the bacteria that could then make you the urolithin A.
Yeah, and that's what kind of I was alluding to in geographies where there is a culture to eat fresh from the farm, like or fresh fruit. People eating a lot of pomegranates and red berries, which also are rich in elagitannins, and walnuts and pecans. These are the typical populations where we find a higher number, so about 30-40%. And so, yes, if you would take a lot of, let's say, if you're retraining or continuously feeding your
Mm-hmm.
gut and you're exposing yourself to the precursors, I do think there's a high chance you can probably end up making the molecule, albeit in different levels, because
Mm-hmm.
not all pomegranates have the same level of elagitannins as well.
Yeah, that's true. And like I am actually a person who eats pomegranates like very seasonally, like wintertime. They're available in the grocery stores here in the USA. So
Mhm.
I buy them and I eat them like at least every other day. I have a bunch of them. Like what part of the pomegranate do you want to eat? Like when you open it up, is it actually just like the real white skin? Is it the dividing parts that divide it into sections? I mean, obviously the pomegranate seed itself is the fruit is feels good, but like what do you eat? Where is it concentrated?
Every, you know, if you take that hard shell out, anything inside, you just grind it into a juice, and you'll get exposure to the precursors.
Mm-hmm.
Most of them is, anything white that is part of the pomegranate, not the red part,
Mm-hmm.
is the healthy stuff. So most people throw that white skin that kind of separates all the clusters of the
Mm-hmm.
arrows, as they call it, and that has the real good stuff.
Cool. Okay, so now let's talk about the journey. Like, let's say that regardless if we're eating a pomegranate or we're taking a urolithin A supplement, it
Mhm.
gets absorbed into the body, and then what happens? Like, it's now in blood circulation. What's the journey that happens biochemically once we take urolithin A?
So we've studied this a lot. We've studied it on a fasting state. We've studied it with food. This is a very, how do I say, it's a very robust molecule. So its absorption and kinetics of, let's say, showing up in circulation are very similar, irrespective of what time of the day you take it, whether you take it with diet, heavy breakfast or not, or heavy meal or not. And so what happens is once you absorb it, a lot of it will go through the gut circulation and get flushed out, and about 20% will get absorbed through the liver metabolism into your systemic circulation. And and what we see is almost about 6 to 8 hours is when, from the first time you take, so if you're taking the direct supplement, you'll see it almost 6 to 8 hours peeking into your blood and
Mm-hmm.
going to target organs where mitochondria are impacted by it. And if you're taking it through the juice, that you need to give yourself time for the gut microbiome to process and digest the L-glutatins, and then you see it more about 24 36 hours. So that's the journey of the molecule, whether you're taking it from nature or direct. So the whole idea of supplementation is majority of people can make it, or make it in small amounts. Can we short circuit and give a calibrated dose? Much like how you would approach vitamins and mineral supplementation. And so that's what we have done.
So this will trigger mitochondria that are expressing surface proteins that they have some degree of damage or are ready to be recycled. It will just trigger and speed up that process. Is that what's happening?
It's exactly what happens. So mitochondria that are damaged, essentially, there are a couple of pathways, but one is a protein called parkin,
Yeah.
that is really expressed in damaged mitochondria, and that's how. Even in when we do muscle biopsies and we look for the amount of damaged mitochondria, we do something called a parkin staining, and we can see the amount of parkin. It's also the protein that goes up in damaged neurons with aging, and that leads
Yeah.
to something called Parkinson disease, which is basically coming from the
Yeah.
mutation of the parkin protein. So
Yeah.
that's how this molecule knows which are damaged mitochondria that have this eat me signal. It hits them directly, and then kind of puts them in this recycling process.
Got it. So is it interacting? Is urolithin A interacting with the Parkin surface protein like directly? Is it blocking, which I saw another in my research of this USB 30, which is another surface protein that kind of prevents mitophagy? Like, I don't know, we need to go down the rabbit hole too hard. This is more for my own personal indulgence because I know you know the answers to this, but like, how's it happening basically?
Yeah, so there's something called ubiquitination that happens once all the mitochondria that have the parkin protein. Once that gets triggered, it stimulates a whole cascade of signaling pathways called ubiquitination. And these are the proteins that you were mentioning, USB 30, etc., that get triggered. So a lot of pharmaceutical companies are now getting interested in the Parkinson space,
Mm-hmm.
that are trying to now target these damaged mitochondria. But hey, you have natural nutrients that can do the job. So
Cool. All right, so let's talk about some of the studies because I think the unique thing about your supplement versus many other ones is you literally have clinical studies to show
mhm,
efficacy. I'd love to hear about a couple of those.
sure.
Duration. What the studies found and in the magnitude of effect that they found as well.
Sure. Yeah. So the first studies we did were in 2018-19. The first study we published, actually. So the real first study was done in different preclinical models. This is the Nature Medicine paper in 2016 that showed that compared to life extension compounds like metformin, or rapamycin, this was as good as almost like caloric restriction. It was increasing the lifespan of smaller species like what we call worms by about 40 to 50%. Then we moved to rodent trials, putting it in the diet of older animals, and they had about a 40% more aerobic endurance, 10% more muscle strength.
What was the concentration, milligrams per kg, of those studies generally?
Yeah, so these are in the range of 50 to 150 milligrams per kilogram in rodent models. That translates into about fivefold higher when you translate it into human. So we started with doses of 250 milligram in the first human randomized trials. These were all placebo-controlled trials. And essentially, we took a cohort of sedentary older adults because we knew older adults who are sedentary will have some level of mitochondrial dysfunction. And after about a month, we started seeing at doses of 500 milligram and above a very nice dose response of really mitochondrial rejuvenation in organs like skeletal muscle and even the blood cells. And so that was the first study. We compared it to also, for example, exercise, and we saw similar molecular signature that exercise was this molecule was inducing almost an exercise-like effect on mitochondria. Then we went and did two more studies in middle-aged adults, about 50, 55, 60 years old, and the age range was about 40 to 64. This was a longer 4-month trial where people didn't change their diet, they didn't change their physical activity. This was a bit overweight, sedentary population. And about 4 months compared to placebo, we see about a 10% to 12% increase in muscle strength in the legs. And so that's something that was really astonishing for us at that time. And then we did a third trial, again, in older adults, showing that older adults who are healthy, albeit not very active, they improve their endurance by about 20% in both their hand and leg muscles. So these were the first 3 to 4 trials. We are just now completing a couple more. In a group, very athletic people, because the whole idea is, well, yes, in older and overweight people there is mitochondrial stressor. What happens in exercising folks? Would this work as good? And believe it or not, it does work. But it works more on the inflammation side, because these people already have good peak performance and endurance, and it helps them recover better. And that's the data we are seeing with these, all these trials.
That was my initial impression when I read those studies, is like sedentary people are not getting these lifestyle signals of mitophagy that they might get if they're fasting or exercising. So I can see how that would give them benefit. I am interested to see, your athletic population or someone who is doing natural lifestyle interventions for mitophagy stimulation, if there is an effect. So when you say it decreases inflammation, like in what biomarker are we measuring this or seeing? Is it
Yeah.
yeah.
So we looked at things like, so what happens in these, and these are really elite middle distance runners that we focus on. We worked with one of the top sports researchers, and overtraining actually over a season induces some sort of mitochondrial damage, and that is mostly through chronic inflammation in these folks. So the typical 2 markers we focus on is something called creatine kinase, which is a muscle damage marker. As with overtraining, these people have a lot of creatine kinase increasing in their blood, and you can see if you can blunt that response. The second key one, which is an inflammation marker, is something called C-reactive protein, which is basically a marker for whole body inflammation. So we see these 2 markers being dampened. There's actually a new study that just came out, independent of us, using these investigators took our product and did an investigator-led study in weightlifters. And it just came out like a couple of weeks back, and they see similar benefits in younger weightlifters, that it helps them boost their strength and oxidative stress and inflammation.
What was the general effect size of that weightlifting study?
So they see about a 7 to 8% increase in strength, and about a 10% improvement in endurance. And then they see a blunting of both CRP, which is the inflammation marker, and oxidative stress. Now, I think the sample size was about 10 to 15 weightlifters in the Urolithin A group and 10 to 15 in the placebo. The study we have wrapped up is a bit more higher powered. It has about 20 in each arm, and these are all elite runners that go to Olympics and things like this.
What do you think, like, just from a straight lifestyle intervention standpoint? Let's say somebody is doing regular fasting, regular cardiovascular exercise, these natural signals of mitophagy, like how much more benefit would they get from adding urolithin A? I know that's not exactly like a scientific question. I'm kind of asking more for your like opinion and slight intuition on this. Like there's many things we can do and they operate in similar pathways. If someone's doing the lifestyle stuff, is this going to be like a game-changing improvement for them to get in?
Now, the number one feedback, and I do know a lot of top athletes, NBA teams, etc., who are taking our product. The number one feedback is how quickly people can recover. So just, they feel better. They feel less inflamed. They feel less muscle soreness. And we have these scales in all these studies we do with athletes called ratings of perceived exertion. Yeah. They feel just less tired at the end of a 5-kilometer race, if you're a middle distance runner. So there's just a bit more fuel left in the tank and you recover better. That's the top 2 things. The third thing I've heard, and this is something that's giving me ideas to run another trial, is that they see impacts on things like VO2, peak VO2 and heart rate variability, in the right direction. So, these are good digital kind of health markers we can employ.
Cool. And what dose do you take urolithin A at? And I'm assuming based on this that you're taking it on a daily basis.
Yes, I have. I always say I'm customer number 1. So I've been on it for 4 years. 500 milligram, I believe, is the foundational dose. So that's the dose which, if you're doing all the things right, as you mentioned, if you're eating well, if you're exercising right, that's the dose you need, because you need to keep your cellular health. To me, is like the foundation that you don't see, right, of your house. And so that's kind of what nourishes good cellular health. Now, there are days where I feel a little less in the tank, or if I go have jet lag, if I'm, shuttling travel between US and Switzerland where I live. That's the day I up the, for a few weeks, I up the dose to a gram. And that's, and then I go back to maintenance dose of 500. That's kind
Hmm.
of how I take it.
Great. Do you take any other supplements like creatine or molecular hydrogen or any of these other things to support mitochondrial health?
Yeah, I really like creatine. I think it's a great nutrient, and with a lot of good clinical data for strength, and just not for muscle, but there's also a lot of cool data for cognitive health on
Hmm.
creatine. I take vitamin D just because I'm always low in vitamin D,
Yeah,
and that's probably one of my favorites. And omega three, I think the data on omega three is is,
for
is
sure.
also is also very good. So these would probably be magnesium would be something that I want to take, but I think integrate.
I hear you
But
on
I'm
that.
yeah always trying to find the right magnesium supplement.
Those are great staples for sure. Um, Now, I hear a lot of like, and you mentioned this before about
Yeah.
rapamycin, which is a drug that works in similar pathways, blocks mTOR, can I think stimulate mitophagy as well. That's part of its mechanism of action. Like again, how does urolithin A, compare to someone who's really serious about longevity and might want to take low dose rapamycin? Are they complementary? Are they basically working on the same pathways? Do you have a preference of one over the other? Probably urolithin A.
So rapamycin is a great molecule. I think it's very well uh, characterized as an mTOR inhibitor. I think urolithin A is more ubiquitous. It does hit a few key targets, involved in the aging process, which probably allows it to hit a bit more of the spectrum of the different pathways or hallmarks we talked about. The one area where I think it really stands out is rapamycin is an immune suppressor. It has been used as an immune suppressor for a lot of transplant and things like graft versus host, diseases, etc. Um, that's where I don't. So we've just finished a trial with the Buck Institute of Aging with Professor Eric Verdun there. This is more of an immune modulator. So depending on the physiological stress in the body, it kind of tunes you out. So I see it more as hitting inflammation, chronic inflammation, and mitochondrial rejuvenation, both as a double-edged, solution. Rapamycin, I think, will not have this double effect that it will hit the mitochondria. It will. I don't think it will. And it may hit the immune system, but suppress it completely.
Okay. That sounds good and very fair. Now, I suppose, kind of like to wrap this up, urolithin A is a part of a holistic approach to increasing mitochondrial health and consequently quality of life and lifespan.
Mhm.
If you can leave our listeners and watchers and viewers with, kind of some encapsulating advice on your breadth of experience about what you think it takes to give yourself the best chance to live well and strong and maybe even make it to 100. Like, what is the recipe, including your lithin A? What would you share with people, like the take home messages and the things to focus on, the things that you believe?
Mhm.
If I asked you to write down on a sheet of paper the core things, these would be the core things.
Yeah, sure. Again, 25 years back when I trained as a doctor, medical doctor, it was all treat the symptoms, not the disease. And I really believe longevity is a marathon, and it's not suddenly when you hit your 65 that you're gonna suddenly lose your muscle function, or your neural brain health or cognitive health will decline. It starts early, and we see that we see uh, in the 40s that this early peak of aging starts, and a lot of organs are struggling, the more the metabolic the organ. So I think having a strategy which improves on all your cellular health is very key as a foundation. And that's where I would fit all these advanced nutrients like CoQ10, urolithin A, NAD supplementation we talked about. And then what I believe is if your core is right, then you'll even absorb things like vitamin D better. I think you will absorb your vitamins better. And then nothing can beat, exercise and 10-15% caloric restriction. Intermittent fasting is just phenomenal for. I mean, I have seen biopsies. I've looked at mitochondria from those people who exercise versus those who don't, and those who fast and those who don't, and it's really black and white. So less stress, better sleep, and voila, that's it.
Yeah, and it's like we know the facts, and it's about implementing them. And so for someone who's listened to this and is interested in trying Urolithin A and trying supplements from Timeline, we do have a special links for our Fit Father community. You can click the link in the show notes, or you can, it'll also be in the email newsletter that we broadcast this out on. And I believe the code is going to be Fit Father Project, where you can try a discount. If someone wanted to try it, like how long would they need to take it to see if they were having better perceived benefit to exercise recovery, maybe seeing some strength gains? Like how long should they expect to take it as like a good starting dose to test it out?
Sure. Yeah. I mean, this is, again, not a magic pill. Okay. I want to be absolutely clear about that. It does take time to have an impact on biology and cellular health, and that's about a month. But people really start feeling the effects around the 2-month time. So I think if you're getting into using it, give yourself a couple of months at least to see some of the benefits.
Cool. Well, this was very informative. I want to thank you for the work you're doing. I mean, it's passionate, intelligent people like you that are bringing these beautiful nutraceutical compounds to the forefront. And I'm very passionate about that as a naturopath myself, is like let's bring good foundational compounds that we can get into our lives and help us live longer. So I appreciate that. And again, if anyone wants to try Urolithin A, basically the only way to get the high enough levels of that outside of, drinking pomegranate juice every day, even if you have the gut bacteria, is to take a supplement, and Timeline makes the best one. So you can go to their website. We have special links as well, and there's promo code FitFatherProject for a discount. And Dr. Singh, thank you for your time today. Appreciate it so much, and the great products you're putting out into the world.
Thanks for having me. I love the discussion. Thanks again.
Thanks for listening to this week's episode of the Fit Father Project podcast. If you love what you heard, please rate and review our podcast on Apple Podcasts. It really helps spread this show to more men who need this valuable info. To watch full video episodes of this podcast and other motivational videos to inspire your training and more, visit our Fit Father Project YouTube channel. It's free, and everything's made for busy guys over 40 like you. Visit youtube.com/Fit Father Project to get access to our entire video library. And finally, if you or someone in your life is interested in becoming a fit father or needs help losing weight, building muscle, and living healthier after age 40, then visit fitfatherproject.com, where you can see our proven programs, supplement line for guys 40 plus, and free meal plan and workouts to get you started. This is Dr. Anthony Balduzzi signing off. I'll see you in the next episode.